Good morning, everyone. Welcome to today's webinar, From Legacy to Intelligent Systems, Modernization in the Age of AI. I'm Revati Kumar, your host for this session. Thank you all for joining us today. We're really excited to have you all here. This session will focus on how organizations can modernize legacy systems, adopt smarter architectures, and leverage AI to build scalable, efficient, and future-ready technology ecosystems. Before we begin, a quick note. This session will run for approximately 30 to 45 minutes. Please feel free to post your questions anytime in the chat. We'll address all the questions via email by consulting our subject matter experts. Here's what we'll cover today. Why modernization matters in today's AI-driven world, key challenges with legacy systems, modernization strategies and best practices, the role of AI in transforming applications and operations. So, now it's my pleasure to introduce our speaker, Bhagyalakshmi Murugesan. Welcome, Bhagya. Thanks for being here. Over to you.
Thank you, Revati, for the kind introduction. Hi, everyone. I am Bhagyalakshmi from Hexacom. Today, we will explore from legacy to intelligent systems and how AI is transforming the enterprise modernization. Today, most organizations are still running on a legacy systems. So legacy means like whenever if the business users wants to scale the system, really it is very hard and expensive to maintain and slow down the changes. In this session, we will see how AI is powered to modernize the system, and these legacy systems can turn into intelligent and future-ready platforms. Let's begin. So basically, here I would like to tell you what is legacy system. When we say a legacy is, we're not talking about how the system is built on or when the system is built on and what programming languages is used. We're talking about how the system is designed. So architecturally, how it is designed. The system becomes legacy when different parts of the application are tightly coupled. Mostly, the legacy systems are built as monolithic applications where the user interface, business logic, and the databases are all part of the single system. Because everything is connected, even a small change is one module can affect the entire system or the entire application. I would like to say some real world scenario for this. Let's take kind of any banking system or insurance. The whole application is deployed as one single package. The package might be either RAR file or WAR file. If a small business rules need to be changed, it requires full testing of the entire system and the changes in the database. And also, we need to have a proper plan for the deployment window. This means small change take a lot of effort. So you are seeing, right? What are the things we have to do? So this is called change amplification. Stability over agility. Because of this design, legacy system focuses more on being stable and safe rather than being fast and flexible. They work reliably, but changes are very slow and risky. As a result, it is very difficult for organization to quickly adapt to the new business needs. Right. Why legacy fails at scale? So legacy system usually scale vertically, not horizontally, which means when demand increases, the default solution is to to add more CPU or RAM or bigger servers. So these are the ways to increase the system size vertically. Okay, for example, I can take a payment processing system. When the system was running on a 16-core server, talking about the CPU core, it would handle around 10K transaction per second. Suppose if the business wants to support higher load, for example, if they want to run 25K transaction per second, then we have to scale up this up to 64 core server. Fine. So from 16 to 64, we have to increase the core. When you look at this changes, the infrastructure increased almost 4 times from 16 to 64. But when you look at the performance, it came from 10 to 25 transaction only. So almost 2 to 2.5% only increased. So performance grows slowly, but the cost grows exponentially. So that kind of problem we are facing with the legacy system. So what are the technical changes we need to do in order to modernize the legacy system? So basically, modernization changes three things fundamentally. First thing is architecture, and the second thing is delivery, and the third one is operations. Architecturally, we move from one large system to multiple independent services. In terms, we could call it as a microservices. Each service owns its own logic and data as well as the communication. So that will happen through either API or events. So from a delivery perspective, we move from manual deployments to CI/CD and long releases cycle into continuous delivery. Operationally, we move from manual monitoring to automated observability. Fine. And also, we can support from reactive support to predictive operations. When you look at the real-time example for this scenario, I can take kind of order management system. So that can be decomposed into multiple services. For example, I can take order services, inventory services, payment as well as notification services. So here, each functionality divided into multiple modules or multiple services. So here, order services will have its own databases as well as own deployment pipeline. And also, whenever it is needed, we can scale independently. So that and all can be configured in Kubernetes. Now, a change in the payment system or payment services, it never impacts inventory or order services. So if there are any changes in the business requirement, we can update the individual services and we can make the deployment. So the latest changes deployed in the live environment. Now we are going to see about how we can move from legacy to modern. So this slide shows the core architecture differences between legacy and modern systems. On the left-hand side, if you are looking at the legacy architecture tightly couples the presentation layer, business layer, and the data layer are all combined into a single unit. The user interface is directly bounded to the backend service, as well as the business logic lies reside in the same application, and everything shared one single database. This creates strong coupling and cascading failures. If there are any failure occur in one module, the whole system will get affected. So even a small change occurs, we need to redeploy the system fully. On the right-hand side, if you look at the modernized architecture, they have introduced API gateway and decomposes the simple system into domain-aligned microservices. So here, each services own its own data stores, nothing but databases, and it using the polyglot persistent model. So in a microservices architecture, we no need to depend on a single database. For one service, you could use SQL databases. For some other services, you can go with NoSQL databases. The key shift is independent deployments and isolated features domains. Services can scale at any time and it can be evolved and fail independently. And also enabling faster delivery and better resilience. For example, I can take e-commerce platform. So when a customer completes the checkout process, so here the checkout process means when the order is placed, the checkout service publishes an order created event to Kafka. So Kafka is nothing but a message broker. The inventory service consumes this event asynchronously to reserve the stock, while the payment services process the transaction in parallel. And also, the notification service sends the confirmation to the end user. So, even if the inventory service fails temporarily, the checkout process, it won't affect the checkout process flow. Still, it will work because the services are decoupled and communicates through events. Now, let's see where AI fits in this modernization. So, in modernization, AI acts as an accelerator. So, AI is not going to replace any engineers. First, code intelligence. So, here, AI can scan large number of lines of legacy code bases and automatically map the dependencies. And also, it will identify the technical depth and it can suggest refactoring areas. What used to take architects weeks can now be done in very within some minimum hours. We no need to spend more hours to do that. With the help of AI, we can reduce the timeline. Second, test automation. So in testing area, the AI can generate and updates the test cases based on the code changes and the user behavior. It finds code coverage gaps and predict the regression risk. Significantly, it reduces the manual QA effort here. And the third one is decision support. Definitely that AI helps to analyze the system metrics, usage patterns, and past incidents to recommend modernization strategies. So here we were talking about the development and the QA process and the decision making. So there are a lot of AI-driven tools are available in the market today. So some of the things, the main thing is some of tools are like GitHub Copilot, Diff Blue Cover, and Sonar Cube. We can use these tools to improve the legacy system to monetization in terms of development and deliverables. Overall, AI becomes a co-pilot for modernization, helping teams to move faster, reduce risk, and make a clear data-driven technical decision. Now we are going to see about from monitoring to AI ops. So what's the purpose of monitoring? We need to keep on check the application's health. That is called monitoring. If there are any failures occurs, we have to resolve it. So the traditional monitoring focuses on collecting metrics and triggers alert after something fails, which leads to reactive operation, but not proactive. But if you go with the AI operations, it introduces an observability-driven approach, which means where AI correlates logs, metrics, and traces to understand the system behavior holistically. Instead of static thresholds, the machine learning model, it learns the baseline patterns and detects anomalies in the real time. This enables proactive alerting, early failure detection, and also it can automate the root cause analysis, shifting operations from incident response to proactive system optimization. So there are some tools are available, like some platform like Datadogs, Splunk, and Dynatrace, these tools are nowadays using AI. The machine learning to correlate signals across logs, metrics, and traces for proactive anomaly detection. Now I'm going to talk about that intelligent CI/CD pipeline. So this is a major part of development. So nowadays, DevOps, right? Development and operations can be combined into a single unit. We no need to have two different teams for development as well as operations, right? So CI/CD becomes very intelligent when pipelines not only automate the deployment, but also it will analyze the risk before releasing changes. So how we are going to use AI in CI/CD? When you use AI in CI/CD, the pipeline can study the code changes and test results and past failures to decide how safely a deployment should happen. So based on that results, we can make a decision whether are we going to do the deployment now or we can move it later. So based on this, it can choose safer strategies for risk changes and faster release for low risk updates. For example, nowadays everything is in the cloud, right? Whether it may be Azure or AWS or GCP. If you are using Azure, we can go with Azure DevOps. If Azure DevOps also using AI-based pipeline. So that will analyze the pull request changes and test the coverage code changes. If the changes is risky, it triggers a canary deployment to a small set of users before rolling out to the everyone. For example, instead of rolling out the system for 100%, I can make a release for 10%. So only 10% of users only will get the changes. If there are no impacts, then we can roll out fully. So that kind of decision making we can do. Now, security and compliance by architecture. So in modern systems, security and compliance are no longer treated as a separate steps that happen at the end of the development. Instead, they are built directly into the system architecture and delivery pipelines. This means access control and security policies and compliance checks are automated and applied continuously rather than being manual or periodic. So if you are using AI, it will help us to strengthen this by monitoring system behavior in real time. It will detect the unusual access patterns and identifying potential threats earlier. As a result, organization gets scalable and continuous security without slowing down the development. So we no need to slow down the development phase. And also it will enable both innovations and compliance at the same time. So this slide represents the end stage of modernization, which means from legacy to intelligent system, where the systems are not just migrated to cloud, but it became truly intelligent and adaptive. First, cloud native foundations, which means what? The system is built using containers, Kubernetes, and some serverless technologies. This allows the application to scale automatically, support multi-cloud, and be managed using infrastructure as code. Next, AI-assisted operations. So maximum, it will focus us on how AI helps in a day-to-day operations. This includes automated incident response, self-healing systems, predictive maintenance, and intelligent capacity planning, which reduces manual effort and also operational cost. And the third one is continuous optimization, which means the system keeps improving itself. Using machine learning, it can optimize the performance, tune resources, and control cost automatically without human intervention. Finally, we can go with the innovation velocity. What do you mean by innovation velocity? It will talks about how quickly the business can deliver new features to the customers. With the parallel development, features flag, and experimentation platforms, teams can release more faster, test ideas, and roll out the changes in a controlled way. So, overall, the systems are not just modernized systems, they are self improving platforms that continuously adapt to business needs and technical constraints. So, here we need to look at the business needs always rather than technical constraints. Are you ready to transform? As we come to the end of this session, I would like to leave you with one simple thought. So, the modernization is the edge of AI is not just about updating the technology, it's about rethinking how the system are designed, operated, and evolved. So, the journey from legacy to intelligent system may seem complex, but it is absolutely achievable with the right approach. So we need to follow the right roadmap, and also we need to have the right partner in terms of organization. The first step is to understand where are you today through the modernization assessment. So the first stage from legacy to modernization, we have to do the assessment. So that is the first phase or initial phase. Then we have to define a clear architecture roadmap, and we need to set the measurable success metrics and start with simple. We can go incremental transformations. At Hexagon, we combine deep technical expertise with AI driven tools to help the organization to modernize their system safely, efficiently, and also intelligently. So, here the key message is this: don't try to modernize everything at one scale. We need to start small. We have to think smart, and we have to build a system which can continuously evolve. Thank you all for your time and attention. I hope this session gave you useful insights. Over to you, Revati.
Thank you, Bhagya. That was an insightful session indeed. So, thank you everyone for attending today's webinar. We hope this session gave you meaningful insights and practical direction for your modernization journey. If you have additional queries, write us to info@hexacop.com. To know more about Hexacop, please visit www.hexacop.com. Once again, thank you, Bhagya, for your time, and thank you all for joining. Have a great day ahead. See you at our next webinar. Thank you.